Norfolk Southern Val Valley branch line, defect, detector, milepost 10.5, online, detector, out.
Welcome to the Val Valley Model Railroad. Today we're going to be talking defect detectors. This is milepost 10.5 on my branch line, and you can see the intermediate signal lit yellow. And just behind that is the defect detector. So here we are with a close-up shot of the defect detector. And before we go any farther, we should probably learn what a defect detector really is. So I found this short clip on the internet that explains a defect detector much better than I could myself. Let's take a quick look.
We're going to look at railroad defect detectors. Beginning in the late 70s to early 80s, North American Class 1 railroads started adding radio transmitters with mechanical voices as defect detectors. As the train passed the detectors, the mechanical or pre-recorded voice would sound out the railroad's main radio channel that a train had passed and note any defects that were found. Most often, after the train passed such equipment detector, the mechanical voice would report the railroad name, milepost or location, a track number if applicable, and on some railroads, such as CSX, they'll list the number of axles on the train that passed, and all this is followed with the phrase, "no defects," to indicate no problems were detected on the train. Sometimes the location's ambient temperature and train speeds are also noted by the mechanical voice. When a problem is detected, the mechanical voice will often start with a long, high-pitched alarm tone, followed by a description of the problem and the axle position within the train where the problem occurred. Crews can use their touch tone hand radios to get the detector to repeat error messages. Defect detectors are equipped with such a mechanical voice are often called talking detectors by railroad crews and rail fans. And a lot of rail fans will use these detectors along with mainline signaling to be able to keep up with where the train's at. Now we'll safely get in a position where we can use zoom and look at some of the parts. For detecting dragging equipment, a cone-shaped column sits across the whole width of the railroad. You see it there. Attached to a switch, anything dragging from a train will hit the cone, thus pushing it back and breaking the contact. Then it returns to its normal position to prepare for anything else that might be dragging onto the train. The detector will register the action of the flag it has a defect. Brittle bars are still used elsewhere, but still have to be repaired over time. Dragging equipment detector metal flaps need to be replaced because of extensive damage from stuff hitting them. For hot boxes or hot bearings, two infrared eyes sit on each side of the track. You see them there. Staring up at the train's bearings. They register the radiation from every journal that passes over it. If a bearing reaches the maximum temperature for safe travel, the detector will flag and count it as a defect. Some defect detectors will have a white pad on either side of the inside rail. This defect detector does not. Most of these features are used on main lines that see a lot of double stack trains. And what those white pads do is detect weight from one side of the car to the other. And this helps detect if that top stack on double stack or top container has come loose and shifted. It will pick that up in weight from one side to the other. One side will weigh more than the other. Now let's listen to a Norfolk and Southern defect detector.
99.0, no defects. Norfolk Southern, milepost
All defect detectors are attached to a cooled building, and there's a fan on the back so I need to keep all the electronics cool.
Okay, we're back from looking at our defect detector, and this again is my scratch built one. I'm using a track sensor switch here, and it has a little tab right here, and every time the axles roll over they push it down and it makes a switch contact, and that's what these cables run into, and it's powered by an Arduino. So whenever the train rolls over it, it counts each axle, and then it waits a certain amount of time between axles having pressed the sensor to determine that the train has passed, and then it will give us count on how many axles, if there was a defect. The defects it makes up at random itself. The first random choice it makes, is this going to be a defect or not? And then it looks at the number of axles that it had, and it picks one, say 44th rear end, and then it'll pick from 1 to 6 defects. Let's take a look at it in action and see how it works.
Norfolk Southern Val Valley branch line, defect detector, milepost 10.5, total axles, 50, no defects, detector on it.
So that time, no defects. So we'll go take a look at the defect detector itself, and then we'll see if we can cause a defect with it. Okay, so we're underneath the layout here, and this is my defect detector. This is the bottom board, which is real hard to see, is an Arduino Uno. And the text board, which is mounted right here, is an Emic 2 text speech. It translates anything sent to it in text into speech. And that does create a bit of a pause after the computer sends it the code to speak. But in a nutshell, that's all there is to it. It's a Arduino Uno. The voice comes from the Emic text to speech module and puts it over a computer speaker. The system is actually kind of simple. It has 2 contacts, which are the switch. We have a 12 volt power and a 5 volt power. The board itself, the Uno runs off of the 12 volts. The Emic runs off of 5 volts. And then we have a speaker connection. The development of this was kind of rough because this is a simple-minded computer, but it does things extremely fast. You would think pressing a button and counting axles would be a very simple thing to do. Problem with that being, the computer runs in a cycle. This is a simple-minded computer, the Arduinos. It's not like your desktop or your laptop or even your cell phone where they can do several things at once. This is like a flow chart. It has to run it in sequence. But it runs its program in a loop, and it does it a couple thousand times a second. So if a button press, if you think about an axle rolling over a button or a photo cell, it would be real easy for it to count a single axle press as a couple hundred axles. And that was my sticking point for a long time. But what we finally came up with is, in the Arduino world, there's a thing called change of state. That means when the button's pressed, it knows the button was pressed and it marks as pressed. It's when it becomes depressed that it actually counts the axle. So it's a 2-step part. And then it times between the next axle that comes, and if it's within a time limit, it continues to count. If the time limit has gone on too far, it'll say, okay, the train has passed, and it'll give you a train reading. Much like this. I just pushed the recall button on the control panel, which allows us to bring up the last
Norfolk
message.
Southern Val Valley branch line, defect detector, milepost 10.5, total axles, 50, no defect.
All right, so I'm
Detector
going to
on.
back the train across the defect detector one more time. Instead of going uphill, this time we're going to go downhill. We'll see if this time we get a defect.
Norfolk Southern Val Valley branch line, defect detector, milepost 10.5, defect. Defect detector, head and axle 16 flaps, hot north ring, total axle 17. Norfolk Southern Val Valley branch line, defect detector, milepost 10.5, defect. Defect detector, head and axle 16 flaps, hot north ring, total axle 17.
So there we had a defect. Well, I hope you've enjoyed a look at my defect detector on the Val Valley Model Railroad. Thanks for watching.